Hey, welcome back. Right now, we're just going to talk about the different types of circuits we'll be studying, um, the parallel circuit and the series circuit. So once you've got all your components for a circuit, that is the battery, the wires, and at least one resistor, we're only going to look at these two types of circuits. Um, Series, where the resistors are all in a row, and parallel circuits where the resistors are kind of each in their own branch of circuit. For this week, we're only looking at the series circuits, and the simulation assignment you have at the end is only focusing on those types of circuits. So that's all we're going to mention now. But before we jump into the circuit analysis, we need to talk about a couple of additional rules that go for both of these different types of circuits. These rules were discovered by another German physicist named Gustav Kirchhoff, and they're referred to as his junction rule and his loop rule. I'll tell you about the junction rule first. The junction rule has to do with current. It's also known as Kirchhoff's current law. Gustav Kirchhoff noticed that when you have current running through a wire, if you allow that wire to split in at least two branches, the total current you have leaving is the same as the total current you had entering that junction. Now, the junction is just a word for where wires meet. This picture here has, let me grab the pointer. This picture has one wire here, and then the wire splits, it goes up, and then it goes down. So the junction is, again, the point of intersection. As I said a minute ago, the total current coming into the junction is equal to the total current leaving the junction. So in this example on the screen, we have 11 amps coming into the junction, and then we have 7 amps going up and 4 amps going down. 4 plus 7 is 11. So all of the total amps, the total current, or the total charge from the electrons as they flow is conserved. And that is the basis for this law. Charge is conserved. If you have 11 amps coming into a junction, you're going to have a total of 11 amps in the circuit somewhere. Now, it didn't split 50%, 50%. It doesn't have to do that. That's not what the law means. It just says you're going to have the same total amount. The electrons with their charge are not going to jump out of the circuit. They're not going to somehow be consumed in the circuit. So it's really just a matter of conservation of charge. I've got 11 coming in. I've got 11 going out. Could be 5 and 6. Could be 10 and 1, 7 and 4, something. I just want to point out again, charge is just the intrinsic property that electrons carry with them. It is not burned up in a circuit. It's not used up. Voltage is what is used up as the electrons go around the circuit. Just to see the junction rule again, here's our battery. We can think of that's where the current's coming from. If we have 3 amps coming into this junction, well, it's going to split. Some's going to go one way, some's going to go another. In this example, we have 1 amp going this way, 2 amps going this way. Together, they make 3. Circuits, don't consider circuits that have branches like this with junctions. Don't think the electron is going to take the path of least resistance. That's not true. If you have 2 branches with wires, let's say maybe this top branch here had 10 ohms of resistance and this one had 5. That means the current will split in a 2-to-1 ratio. If this is 5 ohms and this is 10 ohms, we can expect twice the current to go through here versus this. It's not that all the electrons will take the path of least resistance, just more of them will. Just want to make that clear because I've seen a lot of confusion with that idea before. One more of the Kirchhoff rules, and that has to do with voltage. It's called his loop rule. If we just consider a single loop of wire connecting one end of the battery to the other, we'll have resistors in that loop, but the loop rule says that the voltage you gain from the battery has to equal the total voltage you lose going through the resistors in that loop. So again, current flows through, that's not consumed. Voltage is gained from batteries and lost as the electrons push through resistors. So again, you can get away with considering voltage energy. It's not energy, but it's closely related to energy. So conceptually, you can consider it the same. So the electric potential or voltage we gain in the battery, let's say it's a 9-volt battery here. We gain 9 volts. The electrons, they flow through. They pick up 9 volts as they go through the battery. Going through this resistor, they burn some amount, and then they burn some more going through resistor number 2, and then they go back to the battery. The total voltage they lose between the combination of both of these resistors has to equal the 9 volts we got from the battery. So if we know this is 9 volts in the battery and we burn 2 volts going through resistor number 1, we know for sure we're losing 7 volts going through resistor number 2. The electrons aren't going to say, oh, let's just burn 1 volt here and 1 volt here, because then you're going to gain 9 volts back. And if you start off with 9 volts and then you come back and you gain 9 volts again, but you didn't drop all those 9 along the way, now all of a sudden you have more voltage than you started with. That's not going to happen because of another conservation law of physics, the conservation of energy. So both of these Kirchhoff rules are rooted in conservation laws. Junction rule for current is conservation of charge. This loop rule for voltage is based on the conservation of energy. These two laws combined with Ohm's law will generate all of our circuit equations for both of our types of circuits. We're not there yet. I'm not going to throw any more equations at you this week. The simulation that you're going to attempt soon is all observation based with a couple of tools to help us take measurements. But I do need you to watch the next video so you see how to take those measurements with the simulation. But perhaps before you watch the next video, you can take a look at exit ticket number 6. It's only addressing these first 2 videos. I'll see you in the next one when you're done with the exit.